Hello and welcome to this Critical Updates webinar. My name's Tony Gray and I'm Chief Executive of TCCA, the global representative body for the critical communication sector and advocate for open standards. Today's webinar, hosted by TCCA and presented by Dr. Fidel Liberal, coordinator of the MCS TaaSting project from the University of the Basque Country, and Michael Prosler, founder and CEO of GridGears, focuses on the Mission Critical Testing as a Service, or MCS TaaSting project. TCCA, University of the Basque Country and GridGears are some of the partners in the project, along, for example, with our colleagues PSTA in the USA and other open standards advocates. We have registered attendees with us from around the world, so we're looking forward to an informative and valuable presentation for everyone. Please submit any questions you may have during the course of the webinar using the questions pane on the right-hand side of your screen. If you're on a mobile phone, this appears at the bottom of the screen. If there's time immediately after the presentation, Fidel and Michael will answer as many as possible, and any that don't get addressed during the webinar will be responded to afterwards. TCCA is delighted to be part of the MCS TaaSting project, and I'm now pleased to welcome your presenters for today. Gentlemen, the floor is yours.
Okay, thank you very much, Tony, for your nice introduction. So my name is Fidel Liberal. I'm a full-time professor at the University of the Basque Country. I'm gonna explain a little bit what's MCS testing about. So first of all, a little bit of background about the MCS or Mission Critical Services certification. So as you may more than probably know, the MCS certification is currently under a chicken or an egg issue. So far there was no MCS testing equipment available. So that means that cannot be a certification program in place, and this no doubt jeopardizes customers' confidence. So it's pretty clear that there was and still is a demand for test equipment, but unfortunately this is a niche market. Apparently there has been no business case so far for the big test equipment manufacturers to put this forward. So meanwhile, when no certification programs in place, so there's been some abuse or at least misuse of the whole MCS or MCPTT term in terms of compliance. So more than probably you can see out there something like MCPTT align, like when mentioning some commercial communication solution, or 3GPP ready, even someone claimed certified on the ETSI MCX plug test, which is clearly an abuse of the term because ETSI doesn't certify any conformance or any interoperability certification, but also they only certify the attendance to the plug test. Even you can see some solutions that are already available in some of the already available MCS network application store repository and so on. So it's clear that this is jeopardizing customer confidence. So it's kind of difficult, and we've heard this a lot from ministries and network operators out there. It's really difficult to write an RFI and RFQ with the proper requests, and on the other side, for the providers, for the supplier, it's not easy at all to write or justify, let's say, the added value or in terms of protocol or standard conformance of your solution when compared with others. So why this need for MCS certification is more clear than ever. So first of all, because as you know, the first flagship project or national-wide big scale MCS communication networks are currently under the early stages of deployment. And we all know, and this has been proved once and again, that the standard compliance and interoperability has been the key for fostering innovation and competition in open markets, so that we avoid the vendor lock-in from the very beginning. And even in this new MCS communication framework, the certification needs are higher than ever before. Why? First of all, because the release cycles in the current technology are more quicker, like not only because 3GPP releases are out there every year and something, but also because normally you deploy your MCS at this client on top of our mobile OS platform, no matter whether it is Android-based or iOS-based, and even the operating system, the APIs, and even the chipsets, they change in a kind of regular basis. And not only because of these technical, let's say, new conditions, but also because in the foreseen MCS arena, there are more stakeholders and more complex relationships among the different stakeholders. And I'll try to show you why. So normally, when you, as a UE vendor, try to certify your device for a specific market, no matter whether it's European market, US market, global wide, or even for a specific operator, you bring your all-in-one commercial off-the-shelf device, which is all-in-one bundle with ranging from the RF up to the service level, including the apps or even Volte or whatever service you deploy on top of that. And the certification scope is the whole terminal. But this is not the case for MCS. What we know today is that most of the flagship projects and the tenders out there, they demand the possibility to deploy the MCS client or the MCS service on top of different UEs, even on top of commercial off-the-shelf devices. So now the question is, what is the certification scope? Whether you need to certify every single combination of MCS client and MCUE vendor, or for every other combination of operating system, API, chipset, or whatever. So that's why the foreseen needs of certification have grown dramatically. So first of all, well, apparently we've discussed so far that there's a need for certification, but there are different types of testing and certification schemes. So we can try interoperability certification, which means that you certify that the client from vendor A can talk to the server of vendor B and vice versa. You can certify or test conformance, so check whether some system follows the standard or some kind of or some part of the protocol or subset of the protocol properly. You can even test that one solution or another solution or the network fulfills the demanded KPIs, the so famous 300 milliseconds for multi-year delay. And also you may want to evaluate real devices on real networks in order to validate that they can be deployed on the field properly. And there are several different standard organizations and industry organizations and so on that have been dealt with this in different public safety or mission critical communication arena so far. So let me try to focus a little bit on interoperability and conformance. So as I mentioned before, basically in interoperability, you will have two vendors. One of them will start some communication, will send some signaling, some message with the relevant headers and all the proper, let's say, bits out there. And then if everything goes right, the vendor B will understand the signaling properly and the communication will be established, so that in an interoperability testing or certification will be a pass test. However, this very same message, when you try to certify this against conformant testing equipment, might not lead to the following to the very same results, because a conformant certification tester checks every header, every field, every bit in the messaging to check whether the signaling is following the standard by the book bit to bit. So as you may imagine, both certifications are really valuable, because you want to verify that two solutions can talk to each other and that both of them are following the standard. But sometimes you may prefer to go through one of them before the other, or vice versa. So in the mobile broadband market, even in the commercial one, the conformance certification process is very well defined. So basically, as you know, 3BP is the standardization body responsible for defining all the protocols and the procedures for mobile broadband, and in our case for MCS, for mission critical services. Out of all these technical specifications, there's a specific working group called Run Working Group 5, responsible for turning all these technical specifications into test cases. So they turn all the different call types and all the different mechanisms and define a set of tables that will result on different test cases in order to evaluate every possible combination of call type, messaging, MCVideo stuff, or whatever. So these test cases are defined in tables, in natural language, if you will, and then there's a specific task force, MCC Task Force 160, that translates all these text, all these tables, all this definition of test cases into pseudo programming language called TTCN3 code that basically defines how a test will be implemented. Just for your, if you're curious, this is how a TTCN3 file looks like. So it kind of looks like a programming language. But the thing is that out of this meta language or testing language, then you need to turn this or compile this into running code that will be installed and run in a test equipment that will need to be certified by the relevant bodies, normally GCF, mostly in Europe, and PTCRB, that mostly applies in the US. Apart from that, you need some certification programs and third-party certified labs responsible for carrying out the real certification test, so that any UE vendor takes or carry out some tests on the test equipment and the certified test equipment on these third-party labs, and if they pass all the test cases defined in the certification programs, they will get the stamp of compliance by the relevant bodies. So the idea was to try to evolve this or to apply this approach also to the MCS, since it is 3BP defines, to the MCS ecosystem. So the situation back in last year was that there was no certified MCS test equipment available in the market. The round 5 TS, the test cases definition activities were still ongoing, and there was no full, mature, complete and verified TTCN3 rules for the MCS services. And meanwhile, the users, the buyers, the customers keep on pushing or claiming the need for that kind of test equipment, but unfortunately, the lack of economy of scale of a big enough market for mission critical communication, and more than probably the rush on 5G certification was no doubt delaying the availability of such equipment. But there were started to be some early initiatives in certification programs, and one of the most remarkable ones is the joint task force between TTCA and GCF that is currently ongoing and close to the first stage. And since they created this working item on MCS last year, and they have been working on this ever since. So if we come back to our previous viewer, that's what you need in order to have a whole MCS certification scheme in place. So there were some pieces still missing last year. So in order to try to help the community and the industry and also the stakeholders, the National Institute for Standardized Technology from the US issued a funding opportunity regarding to mission critical voice testing equipment. And awarded up to $6 million for consortium and vendors interested on building such kind of solutions. So in our case, our MCS testing project is a 2 years project, which started on December last year. We are 7 partners, as Tony has introduced, including the University of the Basque Country, Git Guias, who will be here today in this webinar, Sonim, the UE vendor, of course, TDCA and PSTA, and ANSYS, the EMBMS experts, and Emergence, the experts on MCS standards and solutions. And in our project, we were awarded $3.6 million in order to target 2 commercial solutions that we will describe briefly today. So one of in fact, the first objective we were targeting in our project was to help getting or building a comprehensive MCS TTCN3 suite. And in order to do so, we gathered together experts on the UE side. That's why we have a UE vendor on TTCN3 rules. So we have a TTCN3 expert on board, and also on the client on the server side in order to troubleshoot the protocol and so on. And the first idea was, or the first objective, sorry, was to contribute to the activity on RAM5 and also TTCN3 troubleshooting, with the final objective of have as soon as possible a stable set of verified TTCN3 rules for MCS release 13 and 14. Out of these TTCN3 rules, the next step was building, or will be building the TTCN3 tester, which is the engine that turns these TTCN3 rules developed and released by TA160 into a running the test engine, into a running device. On parallel, we have a very clear target in order to push and contribute to the definition of MCS certification or recertification programs. So it was not only a technical, the project was not only a technical, let's say, target, but also a practical one, a certification one. And with all this, with the tester and the certification program, the target was deploying this in a testing and service platform that we'll explain in detail later, and to deploy it not only on a over IP way, but also in a real RF capable device that enables plugging UEs with LT capabilities and evaluating them. And once we have all this in place, to deploy and test the certification program and tools in a living testing lab, so that we can also feedback the whole cycle and improve the different objectives. So at the end of the project, as I mentioned, we expect to contribute to have a more complete RAM5 test cases, verified TTCN3 code and tester capable of validating these test cases, 2 commercial products, the testing and service platform as an RF capable device, and the certification programs to evaluate in the testing lab that we will be deploying in the project. So just quick comments on maybe a little bit technical matter on 3BP. So just for everybody's information, in order to evaluate how the testing will be carried out, 3BP RAM5 defines not only the testing mechanism, but also some reference points that will be tested. This is more or less the architecture, and that is a very simplified high-level view of an MCS ecosystem. But so far, 3BP and we as a project has focused only in these reference points in the client-to-server interface, so that we will be testing clients and the system simulator. So the client will be the UE under test, so the system under test, and the tester will impersonate or will be the MCDT server or a simulation of the MCDT server. And they also define the so-called testing models, which define which part of the protocol stack will be tested, because there are in principle 2 test models. The classical one is so-called UE model. UE model stands for the air interface in an LTE network. Is the one that was traditionally tested in telco equipment and covers from LTE physical layer up to the service layer. So it's complex because you need to deal with all the protocol stack, and so it's mostly under the capabilities of traditional tester manufacturers, which demands also kind of big investment and needs to take advantage of economy of scale. So this kind of model will allow testing not from, as I mentioned, from the physical layer up to the MCS client. So the certification scope would be the whole protocol stack. And this was defined from the early version of round 5 MCS test cases technical specification. Since this was very complex and apparently there was no product out there or no manufacturer willing to develop this for this market, 3PP decided to allow an over IP and over-the-top testing mechanism, the so-called IP model, which cannot guarantee the mission critical features, which are not that much when compared with commercial LTE, but there are, like the MBMS, mission critical QCIs, and the integration between the MCS client and the UE. So that now what we will be evaluating is not that much the vendor, but mostly the application of the MCS client on top of that, so that we will run this test over any IP network, because it's totally seamless to the underlying network. You don't need to use LTE. You can use Wi-Fi or run over wired interfaces or whatever. And the certification scope is only the upper layers, or the signaling, so covering all the MCS signalings and media and for control and so on, but no LTE parts. So this was included also as a proper model by round 5 afterwards. So in our case, one of the first product we will be covering is this testing as service. So our aim is to deploy the tester on the cloud, so that allowing anyone, meaning not only developers but also customers or purchasers, to run test cases without buying a very expensive testing device on house. And it will help also the continuous integration and testing. And this platform will provide a set of tools in order to make the testing or the certification process easier, like test case management, the execution control, and a set of front ends in order to compile results, so errors and so on. Again, we will be testing the client-service interface and deploy the IP model and cover all the MCS signaling and media certification. But we wanted to go a little bit further, so we propose to use what we call 1.5 model, but it's actually called, or there was already a model in 3BP very similar to that, who was the IMS IPCAM model, when we basically go from the very complex UE, let's say from the very simple IP model to the too complex UE model by providing MCS testing and a device capable of evaluating the mission critical, only the mission critical capabilities on the LTE stack. So only these mission critical features, like the setup of mission critical BRS, or the famous mission critical QCIs, and in case that the EMBMS is in place, the handling or the proper handling of the EMBMS multicast group calls and so on. So in this case now, as you may see in the image, we have a real mission critical LTE connection from the UE to the test equipment, so that now we are testing not only the MCS client and the IP layer, let's say, the over the top, but we are also covering part of the LTE stack, because at the end we rely on the device being also LTE compliance device, because it needs to run over commercial LTE networks anyway, so that we somehow trust the commercial LTE certification, and we only check the mission critical features on the LTE parts. So the testing scope is basically the two upper layers plus a part of the LTE one. So this model proposal, as I mentioned before, was already used some years ago for IMS IPCAN evaluation in 3GPP. So the RF capable tester will deploy the over-the-top tester in-house and provide and support this 1.5 model by evaluating also the mission critical IoT features. In order to do so, we have two different deployment models, so you can run part of the test on the cloud, but you can also run part of the test or all the tests in-house and check the proper LT, VRR handling and mission critical QCIC and BMS processing by offloading part of the test to the local device. And you can also take advantage of a joint platform for handling all the information. So finally, just some quick notes on the current status, although Michael will provide further details. So far we've carried out a comprehensive analysis of the status of the Round 5 TS and already provide some contribution to the Round 5 meeting that was held a couple of weeks ago. We have also contributed to the enhancement of TTCN3 MCVideo rules, working together with Tier 160. And we have an initial version of the TTCN3 tester implementing these rules and verifying the first set of Round 5 test cases. And for the testing as a service platform, my colleague Michael Prosser from Grid Gears will provide you with more details. Michael, the floor is yours.
Oh, thank you. Perfect. All right, thank you, Tony and Fidel, for the introduction into our project. So my name is Michael Prosser, and I'm the founder and CEO of Grid Gears. And today in this webinar, I want to give you a short introduction of the MCS Testing as a Service platform. So before we start explaining the features of the platform, what it can do for you, I would shortly dive into what systems are we testing, what is the system under test. So, and we see on the radio device markets, we see similar evolution than we have in compared to our private mobile phones. So what is the difference between those two devices? So on the left side, basically the device mainly comes with an embedded software. So the manufacturer of the device is the same who brings in the software. That also means that the functionality is completely determined by the device and its embedded software. And it's very hard to extend it, especially for third parties. So it's really hard to add additional functionality to the device. And it also has limited update and upgrade capabilities. So usually when you have embedded software, you need to flash it from a chip or something, and you need a cable in order to do so. So this is a little limited. So the devices we have on the right side, let's say the new devices comparable to our smartphones. So they ship basically the device. It comes with an operating system, and it usually comes with some pre-installed apps. And as you know from your personal mobile phone, the functionality it comes with is quite limited. And what makes our smartphones so powerful is that they can be extended by additional apps, and that the functionality is completely, the overall functionality, what your mobile phone is capable of doing, is the summary of all the applications you have installed. And additionally, remote upgrades and updates capabilities are coming together with modern devices, meaning that security updates are pushed to your mobile, and basically you can install them, just restart the phone and you're up to date. So in terms of mission critical services, MCPTT, MCVideo, or MCData applications, they might just be applications on the phone. They might be pre-installed and they might have some extended privileges, but in the end, they are just apps on the device. So the question is, do we need this extensibility? Do we need this functionality by apps, or could we stick with embedded software? So since we're living in an interconnected world where technology moves quite fast, we have new systems, new integrations, and this will simply, you will not be able to keep up with embedded software in that way, mainly because there won't be one device vendor with embedded software who can do it all. So you need this extensibility by third-party applications. The biggest difference between those devices is mainly the amount of software. So when you take the overall comparison of the software running on the left side, it's much less than we have on modern devices. So why does this matter? Software has usually much shorter life cycles than hardware. So if you imagine, for example, your mobile phones, let's say the bigger phone vendors, they release their the new phones on a yearly 1 to 2 yearly basis. But for example, if you take Android, for example, they release security updates for the operating system every month. And if you dig down to the applications, you may have weekly or daily updates. So in terms of mission critical services, you might not have daily updates, but for sure it makes sense to bring in the crucial security updates. So you might have updates on a monthly basis. And of course, updates either to the operating system or to apps like MCPTT apps should not break standard conformity. So what we need is having those short life cycles is a fast and easy way to verify the standards. So we had this in mind when we thought about what are our goals with the MCS Testing as a Service platform. And we said for us, so on the one hand, we really want to accelerate the development. We want to enable vendors of MCPTT, MCVideo, and MCData applications to speed up, making it easier for them to develop against the standards and to be standard conform. And of course, we wanted to build the trust on the buyer side, want to enable the verification of solutions. So as Fidel said in the beginning, there are multiple terms, 3GP ready, and all those terms do not really build the trust, but having a platform where you have verification of the verified test cases, official 3GPP test cases, there you can have the verification of the conformance of the solutions. Another important thing is how we want the platform to be accessible. So we wanted a very easy access and also very low maintenance for everybody who wants to access the platform. And the last goal we set for us was it should be always up to date, you know, that there will be several releases to the standards or updates to the standards. Test cases will be added, will be removed. There might be additional parameters, and we want to provide the platform that to the stakeholders that is always up to date, so you can make sure you're always on the latest version, even though you can always jump back to and test other versions as well. So based on those goals, we came up with our technical solution for the MCS Testing as a Service platform, which is currently under developing in this project, and we building a generic extensible platform, meaning that we could bring even other domains onto the platform. And it's a modular platform, so we have multiple modules for different testing languages, for example. So we support TTCN3 as it is used for the Run 5 test cases, but we also support with a module Robot Framework, which is a different testing language. In addition, as Fidelin said, there are different testing models, and we have modules for those as well. So we enable low latency testing capabilities via an on-premise module, or even via an LTE extension, the testing capabilities over the air interface. In order to make the platform accessible, we went for a cloud-based platform and a web-based user interface. So you have an easy-to-use user interface behind that to control the test cases, to select which test cases you want to run, and also to get the reports. And probably the most important thing is that we run the official Run 5 test cases. So it's not some test cases we came up with, but it's the real integration of those test cases. And of course, we support multiple stakeholders. So this is really one key of the platform, that we want to join and bring in multiple stakeholders onto the platform so that we can enable efficient standard conform testing. Here you see a screenshot of the current state of development. So currently we have deployment in Europe and on the US East Coast. So those are the physical deployments where the servers are. But of course, via the web interface, you can access it basically from worldwide. You will be automatically connected to the closest data center, but you can also switch between them as you like. So who are our stakeholders? So first of all, the end users, the users which are really using the devices, they have a more implicit interest in technical standards, so they don't really care if the solution follows a standard. What they want is basically equipment that just works. So they don't care if the equipment comes from either the device or the software on it comes from vendor A or vendor B. They just want to be able to communicate and they mainly talk to each other or communicate with each other. Then, of course, this equipment has to be bought. So for the buyer's point of view, they, of course, want the users to be safe, that they can communicate in every situation. But they're also focusing on extensible, interoperable, and future-proof solutions, which basically the standards, or if you're standard conform, you get those attributes. But buyers have one problem. How do they know that a solution follows the standards? And there comes our third stakeholder, the testing houses. So the testing houses provide certifications and are able to verify that the vendor solutions follows the standard. And coming to the vendors, as said in the beginning, they're also a great stakeholder of our platform. They provide great solutions, and of course they also want to sell the solutions, and they want to make it public that they also follow the standards. So they want to have that certification in order to have the great market publicity. So now I want to dive in a little bit of the different use cases we see for the stakeholders, and I want to begin bottom up. So we will start with the vendors. So this is just an example of some use cases, and if you have any comments or feature requests or you see different use cases you would like to see, please do not hesitate to contact us. So the first use case is mainly supporting them during development, during the development phase of the product. So we want to provide simulators, tools, enabling free testing in order to speed them up. The second use case is support them during the preparation phase for certification. So to allow them to run through the test cases in order to have an efficient way of the later certification process. And third, supporting them through the whole life cycle. So that means providing regression testing capabilities, integrating it into the build environment of their solution. So one example, for example, how we support the development. Let's say you just started out with developing your solution and you want to implement the first feature of MCPTT. In order to test if the development is standard conform, you would simply log in onto our web interface. It is, as I said, available anywhere, and it's always available. So there's no need for booking time slots. It just is there and you can access it. Even multiple members of your development team can access it at the same time. There's no problem. So after you log in, you basically choose the test cases you want to verify. So you can search, for example, by the feature you want to, or you're just implementing. You get the selection of the test cases. So this is a more free way of testing. And you can even create your own custom test collections you would like to run. After that, you need to specify some configuration. So there are some testing parameters. Of course, you need to specify the environment you're running it in. Here we support multiple environment configurations, and you can save those configurations for later use. And then you run the test cases and you're getting back quite a fast feedback. And of course, a report is generated where you see all your test results, the log views, Wireshark traces, etc. So the next thing is the preparation for a certification. So this follows a more formal process. So instead of freely being able to select test cases, you first file your PICS, your protocol implementation conformance statement. So that basically is a statement where you say you're conformant with those and those features, and based on this statement, the platform automatically selects the defined test cases in order to test that particular feature. And of course, those are the official Run 5 test cases. After that, you still need to specify the test parameters. And once you run them, you're getting back a verification report with the level of conformance, and which is a nice indicator of your certification readiness. And as well, you're getting all the reports with the log files, etc. So jumping into the lifecycle integration. So if you imagine you have once you had your software release out, there will be updates, there will be additional features will be implemented. And what is important is that you do not break the standard conformity. So what we provide is automatic hooks, so multiple triggers. They could either be time or event-based, or even could be part of your continuous integration process. So that means that on every code change which happens during development, there will be automatically a test case execution of specified tests. So you run them automatically, which is also referred to as regression testing. So you make sure that basically no code change breaks standard conformity. And of course, if something fails, you're getting an immediate notification and immediate feedback. So this really limits the risk that additional code or changes in the code jeopardize standards conformity. So coming next to the testing houses, what we can do for them, what we see, which use cases are there. So the first one is definitely supporting them through the whole certification process. So that means the automatic document generation, digital signatures for certificates, such things. And the second one is allow them to support vendors in order to have a successful certification. So the whole pre-certification process, we want to help them to help the vendor. So the certification process, this looks quite much as when the vendor does its pre-certification. So you're specifying the PICs, the platform selects the test cases, and then you can choose your configuration. And what also is important here is that you as a testing house employee, you do not really need to be physical bound to the testing lab. So you can do that completely remotely, and you have different configurations for the different environments. You could, for example, have a lab which is closer to the vendor, or you're quite freely in choosing your environment, and you can, same thing as before, you can store the configuration and reuse it later. So once you run that, the result of a certification process is really the certification report. So this comes with all the documents which are generated, software version of the vendors, names of the personnel who did the certification process. Optionally, it can be signed with a digital signature of your company, and also it includes the whole test case reports and a summary of the test cases which passed or which failed. Supporting this certification preparation, there are several mechanisms too we provide for testing houses. So the first one is this, what I already mentioned, allowing them to support even remotely vendors when they're developing their solution, running trials for the certifications, for example, but also having powerful analysis tools. Of course, vendors also have access to those tools. So Wireshark traces, network traces, log views, etc. So what they can do in order to support the certification, they can basically prepare the whole configuration, even for multiple environments. So everything in order to have an efficient certification process when the vendor decides that he wants to do the certification. So coming now to the buyer's benefits. So these are quite obvious. So First of all, during the procurement phase, you have the ability to verify a solution, by third-party test cases, which are certified by a testing house. So with that, you're getting the benefits of standard conform solutions, namely that your solution is extensible, it is interoperable, and it is future-proof. And the last thing is maybe not so obvious, but as Fidel mentioned in the beginning, what you also can do is that you have your own staged environment, for example, during operations, where you can testing, roll out of security updates, upgrades to the operating system, installation of different apps, and you can even, as a buyer, access the platform to run the standard conformance tests against those updates before putting them live. So that basically limits the risks of updates. So 3 key points I would like you to take away from this introduction into the platform is that, first of all, we are running the official 3GPP Run 5 test cases. So it's not test cases we came up with. It's the official test cases which are focusing on standard conform solutions. And as Fidel said, also we can run them in different models, different scenarios. So you can either run them over IP if you're only developing, for example, the software, the app, or even in combination with a UI when you have a local on-premise LTE extension point. The second thing is mainly for vendors that this platform can really help accelerating the development by integrating it into the development lifecycle and allowing free testing capabilities. And the third thing is really to have a platform which enables the verification of solutions and in order to check for the standard conformity. So what is on our roadmap? So we have a agile roadmap based on the feedback and inputs of the different stakeholders. We will participate in the MCX plug tests. We will have a beta release at the end of the year, and we will launch an official early access program somewhere around March 2021. But what is important for us is that if you have interest in the platform, you can and want to get even earlier access to the platform, you can contact us. We are more than happy to get your opinion. Especially, we would like you to provide us feedback and feature requests. So what you would like to see, what tools you would need or would see where you benefit from. So if you provide us that feedback, that would be really appreciated. So yeah, currently we are under developing, and I did not forget that the fourth big stakeholder, the end users. So as we see it here, if we all come together, the MCS platform, the Run 5 test cases, all the other stakeholders, and the partners of the MCS testing project, then we will also fulfill the biggest user benefits, namely that we have equipment that just works.
Well, thank you both, Fidel and Michael, for that interesting and informative presentation. Just to reiterate a point Michael made there towards the end, don't hesitate to be in touch with the MCS testing team if you want to get early access or if there are features or other aspects you'd like to see included. But for now, goodbye, stay safe and well.